I am super, super excited to be here with Michael Richmond. Not only is Michael a Kubernetes expert, he was also he contributed the founding code that integrated core DNS with Kubernetes. So he is the chief architect of the cloud division at NIO, but he's also rolled up his sleeves and done hard time in engineering as well. And if you think it's impossible to run Kubernetes in production and manage hundreds of terabytes of data per day, we're going to tell you that that's wrong, because they're doing it at NIO and it's super exciting. For those of you that don't know NIO, they are responsible for making the world's fastest electric vehicle.
Yep.
I think, what is it, the EP9?
The EP9, yes.
Yeah, so that's something to sign up for. They've also kind of taken a container native approach to solving their data management and analytics problems. So it's a great story. He's actually done it, rolled up his sleeves and done it. So for those of you that are trying to do it, Michael can help you out. So you've run over 6,700 cores of Kubernetes and DCOS in various data centers in Shanghai and in the United States.
Yes, I was actually totaling up cores in the US this morning of, under container orchestration, we have 13,500-ish cores in the US and about 6,700 in Shanghai.
So I just start off with that to just let you know it's serious, and it's really, and it's happening in production. So that's awesome. But why don't you tell us a little bit about NIO, and I know you have some really cool slides to show us.
Certainly. So as Lisa was saying, NIO is an electric car company founded out of China. We have offices in China, Munich, London, and here in San Jose. And a lot of our autonomous development work is based here in San Jose. So I don't actually remember what the slide order is.
You can see there's a little screen down there for us.
Yep. So I'm a back-end developer. That's been all of my career. This is the first company I've really actually had interesting demos to show other than command lines. This vehicle is our EP9. It's an all-electric supercar that we set a lap record in the Nuremberg Ring in Germany at the end of 2016, early 2017, of 6 minutes, 45 seconds around the 20-kilometer track. This is actually a photo of it in Austin at COTA. We're selling these vehicles they're hand-built. They're really a supercar for the ultra-rich, ultimately. But last July, we started shipping the ES8, which is a all-electric 7-seater SUV into the China market. We've shipped over 15,000 of these vehicles since July and continuing to ship. And the interior photo is a nice luxury premium vehicle. This is all about establishing our brand and getting our products out into the market. But since this vehicle is a modern vehicle competing with Tesla, it provides similar functionality to Tesla's level 2 ADAS functionality. So that would be lane keeping assist, automatic braking, blind spot detection, et cetera. All of that technology in L2 vehicles is based on a lot of machine learning work. And so we are running containers, to bring it back to the topic of this conference, we're running containers in our data center to support that machine learning work.
Excellent. Okay. So why don't you tell us a little bit about your Kubernetes journey and DCOS? I understand both. And how did you decide originally? You're like, okay, we're going to run all of this in containers, because your test cars generate about 15 terabytes of data per day per car, right?
On that order. So we started this project in mid-2016, and we're looking at the industry and deciding between going with a VM-based approach or a container approach. And at the time, containers and Kubernetes were new, relatively stable, but there was really no very few people had any experience that they were reporting in production. But when we looked at the industry, we had the sense that deploying VM-based infrastructure was actually just going to be inventing legacy. We had a bit of runway to build out our system, build out our applications. And so we made a calculated bet that the container orchestration space would mature by the time we needed it to be stable. And that's played out largely the way we'd hoped. There were still two key barriers when we first started deploying containers, and that was how we would solve container networking and how we would solve storage for our container workloads. We have a sizable data lake that we run on bare metal. That's another couple of hundred cores in each of those locations. But excluding that, we needed to have storage that we could present to our container workloads, our container apps, and for that we've deployed Portworx after exploring a number of options, and it's worked quite well. There's been teething problems with Portworx and with our networking solution, but all of those problems are long in our past at this point.
It's been so fun being part of this journey with you and working together to solve these problems. And as we've been hearing in this whole conference, Kubernetes solves a certain set of issues very, very well, but you're right about the storage, the networking, the security, and so a lot of the conversations are now around the rest of the ecosystem, and you guys have been in the forefront. So I got a question yesterday at my booth for someone who came by, wanted me to ask you, how do you get the data from the car to your data lake?
So with our R&D vehicles, they're built out with there's the equivalent of 2 or 3 Xenon class PCs in the vehicles. We directly attach storage in the vehicle, and then we physically remove that storage at the end of the drive. So these are R&D vehicles. So this is all about, we have the sensors strapped onto vehicles like other vendors that you see driving around the Bay Area, like Waymo and Cruise, et cetera, with all of the sensors or growths on the outside of the vehicle. We're still developing the software that needs to consume that data. So some of that software is running in the vehicle, but we ultimately collect all of the data from the sensors so that we can then offload that to the data center and run effectively the same software in the data center and iterate over the software using the type of data that we get straight off the sensor.
Okay. And you guys are doing groundbreaking things in machine learning and IoT, and that's part of the topic that we're talking about here. So how is that learning happening? I mean, what are the types of analytics that are going on?
So a large part of autonomous driving is about recognizing visual data and classifying the objects that exist in the scene, and then starting to develop predictive algorithms of what those objects would be. So a lot of the groundbreaking ML work is about developing the custom algorithms for that. In the Kubernetes space, running stateful workloads in Kubernetes is still an evolving technology. Having storage addressed helps, but you still have things like managing how data volumes move when a container crashes. There's frameworks like Spark that's heavily used in the ML space that have only just last September implemented alpha support for Kubernetes, and so we are experimenting with those technologies. This sort of relates to the somewhat unusual choice of running DCOS and Kubernetes side by side in our environment. This was a choice because when we started the project, it wasn't clear how the industry would move. There were some workloads that were quite easy to set up and run on DCOS at the time, specifically running Kafka, running some databases. Things have changed over time, and as the industry is changing, we are constantly reevaluating where we run our workloads and how much of our environment is DCOS versus Kubernetes.
So the Kubernetes has an incredibly vibrant community, as you know, and as a community I'm very passionate about. In the user group I've run, I think I've run over 20 meetups on Kubernetes now. And we know you contributed the core DNS code, and as I mentioned in the beginning, so how do you work with the Kubernetes community and take, or do you contribute back, or does your team, or do you take input from them?
At this point in NIO's journey, we are focused on achieving our business goals. We have been tracking with the Kubernetes community. We've been meeting with Kubernetes engineers at Google to understand where there are gaps that the core team is unlikely to work on in our time frame, and we are spinning up some work for our engineers to build out, to backfill some of those areas and contribute back, but we haven't actually gotten to that stage yet.
Okay. What's the one of the bigger challenges that you've had to overcome, or like one of the just hiccups you ran into that you had to just say, oh, I have to fix this problem, make this work?
So one of the challenges that we've had over our 2.5-year journey has been the act of deploying and managing Kubernetes. We evaluated a number of the deployment tools available at the time. They didn't meet all of our needs, so we actually started building out deployment tools in-house. The industry has shifted a lot, and we are, just actually last month, we kicked off a reinvestigation into what the current state-of-the-art tools are. We've been running a multi-master Kubernetes deployment since 2016. Back in 2016, multi-master deployments were largely a black art, so we had to develop or build up that experience in-house. We automated and scripted it. But all of that scripting to manage deployment of Kubernetes is actually doesn't move our core business value forward. It's just the cost of doing business with Kubernetes at the time. As the platform has matured, it may be possible to get some of that functionality off the shelf from existing vendors now. So one of the big things about working with Kubernetes we found is the need to constantly reevaluate the deployment decisions and the technology choices. This is like many large open source communities. Back in the OpenStack days, if you leaned on the decisions you made 12 months ago based on the state of OpenStack then, you'd be wasting a whole lot of time because 12 months later, those problems will have likely been solved for you. And I'm seeing the same pattern happening with Kubernetes.
Okay. So let's talk a little bit more about the cars. I think you have another cool car slide. Oh, there we go. Oh,
so this is just another view of the EP9 at COTA. The COTA experience was interesting. If you look closely, there's no driver in that vehicle. This was a couple of track days where we sent the EP9 around the Austin racetrack in a autonomous mode, and it was running at an average speed of 150 miles an hour without anybody in the car. The video's on our website. You can see the entire lap. And then this is a different EP9 at the track in Germany when it was actually setting the lap record.
Okay, wow. So this brings up my question of, so I don't have an autonomously driven car yet. So maybe you can explain to me and the rest of the audience that also doesn't have one, the levels. I understand that there's degrees of autonomousness, and of course I'm curious about as you go from level to level. I don't know some of the NIO secret sauce you probably can't really talk about, but how does that infrastructure change? But maybe you can describe where the industry is right now with how autonomous these cars are.
Sure. So the European Automotive Safety Institute defined 5 levels of autonomy a number of years ago. Level 2 is what you get from a Tesla today or a high-end vehicle, where you get lane keeping assist, you get adaptive cruise control, where the vehicle will speed up and slow down based on traffic ahead, maybe lane keeping assist and blind spot detection. Level 3 is where you start getting into autonomous functionality, where the vehicle is able to self-drive, but the technical definition of level 3 boils down to the occupant of the vehicle must be ready to take over at a moment's notice. And then level 4, the vehicle will give the occupant a window of time in which they can disengage with their current task to get context of the surrounding conditions and then take over driving. And level 5 is basically where there's no need for any controls. Level 5 is a long way off. Level 4, even though they're a linear sequence of numbers, level 3 and level 4 are not an evolution from level 2. Level 2 functionality is part of the foundation for level 3 and 4, but the necessary data rates and processing jumps dramatically. So in a level 2 vehicle, we've been collecting on the order of 1 terabyte of data per hour from the sensors on that kind of vehicle, and that's what our ES8 SUV is delivering to customers. For our R&D vehicles for level 4, that jumps up to 15 to 16 terabytes of data per hour. So just the sensor set.
Per hour?
Per hour.
Wow.
Just the sensor set is massive. The compute in vehicle to handle that data scales at a similar rate. And it's a completely different compute hardware architecture to support L4. So one of the architectures that the industry is using in an L4 vehicle is to have a main autonomous compute device that is keeping track of the vehicle, the objects around the vehicle, predicting their paths, and then planning what the vehicle should do. And then there's often a second emergency escape compute device that's constantly processing, based on the current conditions, if the primary autonomous compute dies, what should the vehicle do to safely escape from the situation, which means either slow in lane, pull over to the side of the road. And this is to provide redundant safety, because autonomous vehicles are when lives start counting on the compute to operate correctly.
And this is where you get into all these really interesting questions about the ethics of how you're writing these programs. It's still humans that are programming, so that's probably a whole other talk. But I'm really curious, as you're going from level to level, you're going to have a requirement from technology to advance beyond where it is today.
Yes.
Maybe 5G is necessary for some of this. Maybe, I think the networking is going to be a really, really key point, storage as well. What are you looking for? What do containers need to do, and other parts of the ecosystem, in order to keep up with what you're trying to do?
So we're purely running container infrastructure in our data centers. We are using this infrastructure currently for the R&D workloads that we've been talking about. I'm actively deploying a different container cluster for our connected consumer vehicles to start connecting to upload data from the vehicle. And that's diagnostic data that is driven on demand for when a fault code is raised in the vehicle, applications running in the vehicle will collect up all of the possibly relevant data and upload it to our service technicians. What containers are bringing to us in this space is really the ease of development, faster development, iteration cycles. It's somewhat providing the value that Java promised to us of my developers can write their code on their laptop and deploy into our data center. And it's not perfect. We can't avoid the QA and the validation cycles there. But ultimately, the container infrastructure largely has made everything look like Linux, and because it is, and that has simplified the problem space of writing code once and running in many different environments.
And you, correct me if I'm wrong, we haven't talked about this for about a year, but you chose to not use a distro. You chose to roll your own Kubernetes. Is that still the case?
That is still the case.
Why did you decide for this?
The distros were not able to provide the deployments of Kubernetes at the time that we needed. So at the time, I mentioned multi-master Kubernetes deployments earlier. If we were deploying the first system that we brought up as a sandbox was about 300 cores of Kubernetes. And there was no way we were going to run 300 cores spread over about 30 machines with a single master. And so we initially wanted to set up a multi-master setup. We've been running latest generation Intel servers. We've had multiple issues where we bring up a cluster and by sheer bad luck, the node we're using for the master actually is the one that has a BIOS or a RAM fault, and that then blocks my entire development team from moving forward until we solve that. So at the time, multi-master, managing SSL certs for the nodes that are based off of our corporate cert route rather than being self-signed were barriers to deployment. And this is why we're actually reevaluating that now, because we have 4 engineers who are largely constantly focused on automating our deployment of Kubernetes and making our deployment repeatable. I'd like those engineers to work on other things rather than just keeping Kubernetes up and alive and healthy.
Did you ever hit a point where you just thought it was all going to fail? You were just panic mode and you had to get over that?
With every data center we brought online, there was that feeling. So the first data center we brought online, myself and 600 other engineers were shipped to Shanghai to a data center that we just rented a private room in. We didn't speak the language. We didn't even know whether all of our hardware got there. It had been racked. The cables were in a box. We had 4 days to bring up these 60-odd machines. That was stressful, and we thought it was all going to either collapse or we'd be stuck in Shanghai for a number of weeks. And then we brought up our US data center at a colo last April, and we brought it up and found that one of the foundational pieces of technology for all of our apps had been misconfigured. And so, but we discovered that during our final validation testing. So that was a couple of weeks of effort that we then took another week to tear down and start rebuilding for the next couple of weeks. Large deployments are challenging, and one of the things that we've done at NIO, which is the reality of the pace that we're trying to move to meet our business goals, is we are scaling before, sometimes we are scaling before we've actually got the core application stable. So scaling before you've actually finalized your configuration makes everything difficult.
Words of advice, you guys, they scale massively. So Michael can give you a lot of really good tips there too. If you go forward one slide, if people do want to ask questions, my DMs are open and my Twitter handle will be on the next slide. And I haven't seen anybody walk by and flash a time at me, so we'll just keep talking until you do. Okay, excellent. So a couple of people have mentioned Tesla on this stage in the last 2 days. The keynote yesterday, I think the gentleman said that Tesla has 65 processors in the car. I don't know if that's today or if that's in the future. NIO does things a little bit differently. Can you, what is your technical differentiation where you don't have to, because you're not running the processor, all the processors in the car, yeah?
The workload that we've been talking about are all data center side. We do have processors running in our cars. The hardware hosting those processors are, many of those components are designed in San Jose. I can't share a count of processors, but it's a surprising number. An electric vehicle, and particularly an autonomous vehicle, ends up being a data center on wheels. And as a small touch point of that, R&D vehicles that we're collecting this data on started off with 2 1-gig switches with 8 ports each. That was 2 years ago. 2 weeks ago, I deployed a 48-port 10-gig switch into one of our mules. And this is being, as hardware engineers, as our sensor engineers have been asking for more things, and as the automotive industry has been moving away from the CAN network to Ethernet-based networking, there's more and more of a traditional IT and data need in the vehicle. If you ever try to find a 10-gig switch that supports PoE on a handful of ports, don't even try. It's like impossible to find. And that core problem right there has meant that I'm now actually running a spine and leaf network topology in our R&D vehicle. And everything we're doing in R&D ultimately translates in some form to one of our future vehicles.
Okay. Oh, we do have a question from the audience. Can you repeat the question for the folks that didn't hear?
The question was, are we using NVIDIA at all, or is everything ARM? We are using a number of ARM SoCs. We have a partnership with NVIDIA, and we are working with them on a number of our components.
Any other questions for folks that aren't on Twitter? Well, I'll ask another one because we talk to a lot of customers, and not just in my day job, but also my evening job of running rather large open source communities, and especially in the Kubernetes and even DCOS, and you are further ahead than most where they're. I mean, right now, who's running Kubernetes in production? Can you show of hands? So I always ask this, and I'm always surprised that it's actually not more people. But usually when it's the in production part that doesn't let all the hands go up, but you're doing it. So for those that are still on that journey and trying to get there, what advice would you give?
Identify your upgrade strategy really early on. We have found ourselves running quite long in the tooth versions of Kubernetes, largely because by getting into production, we now, the risk incurred of a whole cluster update becomes a challenge. So we are redeploying our applications on every fortnight, every 2 weeks. But in one of our environments, we're still running Kubernetes 1.7x. We're hoping to bring that up to 1.9x soon, so we have parity across all of our environments. But even 1.9 is somewhat behind the bleeding edge. And that upgrade cost, or it's not about necessarily the cost, but it's the perception of risk if you're talking about tearing everything down and bringing it back up with stateful applications, because ultimately every application is stateful. You can make a choice of running your databases on bare metal or outside of your Kubernetes cluster or outside of your container infrastructure. From my perspective, that just means I have 2 environments I need to manage. And so we are aggressively pushing to get all of our stateful parts of our workload into our container orchestration as well, with the only exception being our data lake, because we're not running anything else on those HDFS nodes. We're actually migrating from HDFS to another file system, but we still want to dedicate the entire machine to keeping that data lake functional and healthy. And this is largely to prepare for our future. We anticipate having, as you were alluding to in your introduction, over 100 petabytes of data under management in infrastructure in the US. And we have a goal, and I'm terrified by this goal, but we have a goal of recalling all of that data and pushing it through our analytics once a week. And so I need to keep my data lake machines calm and happy without workload there, so that when we get to that kind of recall rate, I'm not overtaxing those machines with processing that shouldn't be on those machines.
And this is a problem. All of you that are in ML or IoT, or so many of the presentations we've seen talk about that data, all of that data that everybody is gathering and that needs to be managed and analyzed. And actually, thank you, by the way, for being a second-time speaker at Container World. Repeat performer. You've spoken now at half of all the Container Worlds that have existed. This is the fourth Container World.
Is there a prize?
There probably is. If you come next year, you'll be like batting over 500. But you had my favorite quote of all of Container World last year when we were on stage. And we were talking about running stateful applications and the necessity of doing that. It's a harder problem to solve in containers than running your stateless applications. And it's where some of the adjacent technologies come in and help. And I asked Michael, about the challenge of running stateful applications. And he said, just to clear up any misconceptions, the only really stateless application that exists is Hello World.
Yep.
And which I've quoted on every presentation I've given for the last year and given you credit. It was my favorite quote because it's really true that people, they need to go that extra mile and they don't know how yet. And you solved that problem. And someone came by our booth yesterday and said, okay, we've been given a hall pass for stateless, but only for about a week. We need to, stateful, sorry. We need to figure that problem out. Can you help us? And so thank you for solving the hard problems and for vanguarding out there. And Michael has agreed to be at our booth in the next room for a little while this morning, so he can answer lots more questions about what he built running these applications in containers, and also about the cars. You can ask him about cool differentiators, like the battery pack that gets changed out instead of gas stations, right?
Yes, actually, I think if I skip
I'll leave you with one more nugget about these really cool cars.
So one of the aspects that we built into our ES8 and all of our consumer cars is the ability to swap the battery out. And so we've deployed these battery swap stations, which you see behind the ES8 in the photo. As of the beginning of this year, we deployed over 3,000 kilometers of highway with these battery swap stations. A battery swap is fully automated. It takes about 3 to 5 minutes for a battery to be dropped out of the vehicle, or for the vehicle to be raised up, the battery dropped out of the bottom, and something equivalent to a large CD changer basically has a number of charged batteries that then get moved under the vehicle and reinserted. There are some YouTube videos of customers who are so excited about seeing this happen to their personal vehicle that it's quite interesting to watch. How cool is that? No more sitting in the IKEA parking lot for 45 minutes while you're charging your Tesla, right? No, it's going to be really, really great. Okay, last chance for questions. Otherwise, we're going to wrap it up and give you some time for the exhibit hall. One more? Are you using a super language or are you using Python for AI or machine learning? Our software engineers and data scientists are using a spread of languages. A number of the ML workloads are being done in Python. Some of our ML model training that's going into our vehicles is being cross-compiled from a couple of different frameworks into C because we need to actually get down to the embedded processors. And all of the, you didn't ask about this, but I'll add all of the metadata indexes that we're building over our data lake and the the software, the application platform that we're using to manage the quantities of data I'm talking about are primarily written in Python. And then we're, as RESTful services using a asynchronous implementation with Tornado. And then we are starting to explore introducing a message bus that is another way of interfacing with that Python workload.
Last question. How are those classes?
GPFS is a file system that I'm evaluating in alternative to HDFS. I've hit some scale limits with HDFS. Gloucester is also something that we've been evaluating, but we haven't actually committed to a path yet.
There was one question here. Gentlemen.
Yes, so Michael, since you're using Kubernetes in production, what kind of monitoring and observability tools are you using today?
Since you're using Kubernetes in production, what kind of monitoring and observability tools are you using today?
So right now we have Prometheus deployed and with a Grafana dashboard. We have the Elk stack deployed for logging, but we are not using, we're using FluentD as the log collector rather than Logstash. And we've actually built up basically a two-tier architecture for our FluentD, where all of our Kubernetes and DCOS nodes report to collect logs locally on the host via a FluentD instance, and then those FluentD instances on each host deliver the logs to a number of, I said at the start of this talk that we avoided VMs. This is the one space where we have VMs in our infrastructure. We have a number of VMs running FluentD as a log aggregator from those hosts, and then that writes straight down to iSCSI volumes. And those VMs, we have a small cluster that is VM-based that runs our management services that we use to bootstrap our Kubernetes systems. So that's a DHCP server, a couple of Pixie servers, et cetera. And these FluentD instances. That management cluster, we are in the process of migrating to be a hand-managed Kubernetes cluster. And that's actually how we are evaluating some of the new Kubernetes distros by saying, we'd like to deploy a new Kubernetes distro. We don't want to disrupt our production clusters, but we can play around with this management cluster, work out a convenient way to manage it if the up-to-date distro management helps there. And based on that, those learnings, we will evaluate deploying them to the production clusters.
Wow, NIO is like the poster child for the CNCF products and technology. I heard FluentD, Prometheus, Kubernetes, of course, Grafana. So good job, lots of great open source technology in there. So let's everybody thank Michael Richmond for his time. Thank you. I hope we'll see you next year at Container World again for round 3, and we'll be at the booth, the Portworx booth, which is in the back corner. So come and ask us more questions. Thanks, everybody. Enjoy the rest of the conference.